Good morning, everyone. Welcome to SE446 Big Data Analytics. I am Professor Anis Kuba, and over the coming weeks, we will explore together the fundamental technologies that power modern big data systems. This course will take you through a comprehensive journey, starting with Hadoop and its distributed file system HDFS, then moving to MapReduce for processing large data sets, followed by Hive for data warehousing, Spark for fast in-memory analytics, and finally Kafka for real-time data streaming. Each of these technologies solves specific challenges that arise when working with massive amounts of data. By the end of this course, you will understand not just how these tools work, but more importantly, why they exist and when to apply them in real-world scenarios. Let us begin our first lecture on Introduction to Big Data. Before we dive into the technical details, let me give you a roadmap of what we will cover in today's lecture. We will begin by asking a fundamental question. What exactly is big data, and why has it become so critical in modern computing? To answer this, we need to understand the characteristics that define big data, commonly known as the 3 V's: volume, velocity, and variety. Then, we will explore the challenges that arise when traditional systems try to handle such massive data sets. This will naturally lead us to the solutions that have emerged, particularly distributed computing frameworks. Finally, we will see concrete examples of big data applications across different industries to understand the real-world impact of these technologies. This outline will guide our discussion today. Let us understand the scale of big data through a concrete example. Imagine what happens on the internet every single minute. In just 60 seconds, 500 hours of video are uploaded to YouTube. 6 million people perform Google searches. 500,000 tweets are posted on Twitter, and 200 million emails are sent across the world. Now, this creates several fundamental challenges. First, the volume is too large for a single machine to store. Second, the velocity is too fast for traditional batch processing systems. Third, the complexity is beyond what simple database queries can handle. As a consequence, traditional database management systems simply cannot cope with this scale. This is why we need new tools and techniques specifically designed to handle big data, which we will explore throughout this course. So what exactly is big data? Let us understand this through a concrete definition. Big data refers to data sets that are too large, too fast, or too complex for traditional data processing tools to handle. To clarify what this means, we need to understand 3 fundamental characteristics. First, the data cannot fit on a single machine. Imagine trying to store petabytes of sensor data from millions of IoT devices on one server. It is simply impossible. Second, the data cannot be processed in reasonable time using conventional methods. A single processor would take weeks or months to analyze what needs to be done in hours. Third, as a consequence, big data requires distributed computing, spreading the storage and computation across many machines working in parallel. It is important to note that big data is not just about size alone. It is about the combination of challenges: volume, velocity, and complexity together.